This is pretty much more of the same thing. Um, Here they just add a couple of steps. 5x squared plus x squared equals 42. Well, I know here that I'm going to combine these two because they're like terms. So really what I have is 6x squared equals 42. Once I combine, I have to isolate my variables. So I've got to get x squared by itself. That means I've got to get rid of the 6. So I'm going to divide by 6. Divide by 6. X squared equals 42 divided by 6. Well, what times 6 equals 42? 6 times 7 equals 42, so my answer is 7. And then I use my radical function. Once I isolate the variable, I use my radical function to square root both terms. Well, 7 doesn't have a square root. It does, but it doesn't have an even square root. So I'm just going to leave it under the radical. X equals plus or minus the square root of 7. That's my answer. Because I can't find the square root of 7. I can, but it's some funny number. It's going to be like 2 point something. Who knows what. If you plug it into your calculator, you can find it. But they don't want you to. They just want you to leave it like this. Under the radical, put your plus and minus signs, and that's what your answer is going to be. Here we're going to combine these two variables because they're like terms. You can only combine like terms. A like term is a term that has the same variable and the same exponent. These two are like terms because they have the same variable, x, and the same exponent, 2. That's why they're like terms. So I'm going to combine them. 5x squared minus x squared equals 4x squared, because 5 minus 1 is 4. Okay, now I've got to isolate the variable. Isolate x squared. That means I've got to get rid of the 4, so I'm going to divide by 4 to get rid of the 4. Uh, 200 divided by 4 is 50. So x squared equals 50. Now I've got to find the square root of x squared. The square root of x squared is x. And I don't know the square root of 50. Actually, 50 doesn't have a square root. So I'm going to leave it under the radical like this. Nothing times itself gives you 50. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. So the number is actually between 7 and 8, because 7 times 7 is 49 and 8 times 8 is 64. So the square root of 50 is like 7 point some decimal number. But they don't want you to find it. They just want you to leave it like this under the radical. Okay, here I've got to isolate the x squared. That means I've got to get rid of this negative 81. First, I get rid of this negative 81. That cancels out. What I do to one side, I have to do to the other. So I'm going to add 81 to this side too. So I get 3x squared equals 81. Then I divide by 3. Divide by 3 to get rid of the 3, right? 81 divided by 3 equals 27. So x squared equals 27. I square root both sides, and I get x equals plus and minus the square root of 27, because I can't find the square root of 27. 27 doesn't have a perfect square root. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. There's no square root or perfect square root to 27, so I just leave it under the radical. Okay, I've got to isolate the variable on one side, the equal sign. So that means I've got to get this 3x squared over to this side. And I've got to get rid of this negative 128. So what I'm going to do is I'm going to add 128 to this side. That's going to leave me, and I'm going to add 128 to this side, because what I do to one side I have to do to the other. So I'm going to have 5x squared equals 3x squared plus 128. Now I want to get the 3x squared over to this side, right? So what am I going to do? What sign is in front of the 3x squared? It's a positive sign, right? So I'm going to use the inverse operation, which is a negative. So I'm going to subtract 3x squared from this side. That's going to cancel out the 3x squares, but what I do to one side, I've got to do the other, so I'm going to subtract 3x squared from this side too. That's going to give me 5x squared minus 3x squared equals 128. So 5x squared minus 3x squared, what's 5 minus 3? 2x squared equals 128. Now I've got to isolate the variable, right? So I've got to get rid of this 2. So this is 2 times x squared, so I'm going to use the inverse operation, which is division. And I get x squared equals 64. Now that I've isolated the variable on one side, to get rid of this 2, this square, I use my radical function. So the square root of x squared is x. And the square root of 64, well, let's see if 64 has a square root. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Cool. 64 has a square root, so it's positive and negative 8. That's my answer. What I'm going to do here is combine like terms, right? 10x squared minus 2x squared is 8x squared. Then I'm going to isolate the variable by getting rid of the 8. Since this is 8 times x squared, I'm going to use the inverse operation of multiplication, which is division. That's going to get rid of my 8. But what I do to one side, I have to do to the other, so I'm going to divide the other side by 8. 224 by 8, 224 divided by 8 equals 28. And 28 does not have a square root. So x equals plus minus the square root of 28. Well, what I mean when I say it doesn't have a square root, I don't mean that it doesn't have a square root, because it does. It just doesn't have a perfect square root. The square root is going to be a number with some sort of crazy decimal behind it. So I just leave it under the radical. Okay. Fractions again, no problem. You have a fraction on this side and a fraction on this side. Whenever you have a fraction on both sides, all you got to do is cross multiply. That's going to be your first step in solving the equation. So let's cross multiply. X times x is x squared, because when you're multiplying variables, you add the exponents. So x times x, we're going to add the exponents. 1 plus 1 is 2, so that's how I get x squared. And then 4 times 9 is 36. Since the variable is already isolated, I just skip to this step, square rooting it. I use my radical function to solve what x is. So the square root of x squared is x. The square root of 36 is plus or minus 6.